Most people believe the great sky events, the ones from the history books, belong to other generations, that you were simply born at the wrong time. You weren't. Astronomers can now run the solar system forward like a film, and when they do, something remarkable falls out of the mathematics. Within the next few decades, the sky is scheduled to stage a meteor storm, a crowding of 5 worlds not witnessed in more than 800 years. And, for the first time since 1818, one planet crossing directly in front of another. Every one of these events has a date. Most of them will ask for nothing but your own 2 eyes and a dark patch of sky, which means the only thing standing between you and the rarest sights the sky can offer is remembering to look up before your time runs out. This is the complete calendar. Every event, in order, with what your eyes will actually get to see, and an honest warning about the ones they won't. So, before you trust the dates in this video, you deserve to see the machinery tested. And it was tested recently, publicly, and under the worst possible pressure. December 27th, 2024. A few hours after midnight, in the mountains of northern Chile, a telescope that never sleeps, part of a network called the Asteroid Terrestrial-impact Last Alert System, flagged a faint dot drifting through the constellation Hydra. The dot was given a bureaucratic name, 2024 YR4, and when astronomers traced its path backward, they found something unsettling. The object wasn't approaching, it was leaving. 2 days earlier, on Christmas Day, it had already made its closest pass of Earth, about 828,000 kilometers, twice the distance to the Moon, approaching from the direction of the Sun, out of our blind spot. And nobody had seen it coming. Within weeks, that quiet dot triggered the first stages of the world's planetary defense protocols. Orbit calculations showed a chance it would strike Earth on December 22nd, 2032, and the chance kept climbing, past 1% the formal alarm threshold. On January 27th, 2025, it was rated a 3 on the Terrestrial-impact hazard scale. Only one asteroid in history had ever scored higher. Telescopes worldwide were redirected. Maps were published showing a possible impact corridor curving from the Pacific across South America and Africa to India and Bangladesh. The object was around 60 meters wide, the size of a 15-story building, the same class as the Tunguska impactor, and it carried the energy of roughly 500 Hiroshima bombs. The press called it a city killer. On February 18th, 2025, the probability peaked at 3.1%, one chance in 32. And then the machinery did exactly what it was built to do. More observations arrived. The zone of uncertainty around the asteroid's future position shrank, and Earth slid out of it. Within a week, the Earth impact was gone, but the Moon wasn't. As the uncertainty region tightened, the odds of the asteroid striking the Moon on that same December morning crept up to around 4%, 1 in 25. And here is what that would have meant for your eyes. An impact carrying the force of about 340 Hiroshima bombs, carving a fresh crater up to 2 kilometers wide on the Moon's near side, the side facing us, and throwing roughly 100,000 tons of debris off the Moon, entirely enough, some researchers calculated, to spark an extraordinary meteor shower over Earth. One scientist suggested the flash of vaporized rock would have been visible from Earth even in daytime. Another argued it could have shone brighter than the full Moon itself. For almost a year, that possibility just sat there, because the asteroid had faded beyond the reach of every telescope on the ground, 63 million times fainter than anything your eye can see. Then, in February of 2026, the JWST caught it twice more, measured its position against precisely charted background stars, and the mathematics delivered its verdict. Announced on March 5th of this year, the Moon is safe. On December 22nd, 2032, the asteroid will miss the lunar surface by about 21,200 kilometers. So the show was cancelled. And you might think that makes this a strange way to open a video about events you'll actually see. It's the opposite, because think about what just happened. Humanity found a 60-meter rock it couldn't see coming, tracked it after it had already left, recovered it with an infrared telescope 1.5 million kilometers from Earth, and pinned down where it will be, 8 years from now, to within a sliver of the moon's width. The dates in the rest of this video come from that same machinery. When it says a meteor storm will peak on a particular November night, or that 2 planets will merge on a specific afternoon in 2065, it has earned the right to be believed. The schedule is real. Now let's get to the part of it your eyes were promised. The first entry on your list is almost here. Before sunrise on August 12th, 2026, 6 planets will stand in the morning sky at once: Jupiter, Mercury, Mars, Uranus, Saturn, and Neptune strung out along a single line. You will not need a telescope to know it's happening. Step outside in the dark before dawn, and the bright ones will simply be there, arranged like beads on an invisible thread. That thread is the whole secret. The solar system is flat. Every planet orbits the sun in nearly the same plane, like marbles rolling on one tabletop, and from our place on that tabletop, all of them appear to travel along a single narrow path across our sky, a line called the ecliptic, the same path the sun follows. So the planets are always lined up, in a sense. The line is built into the architecture. What's rare is the timing. Mercury laps the sun in months. Neptune takes 165 years, and most of the time they're scattered, some lost in the sun's glare, some on the far side of the sky. An alignment is the uncommon moment when all those mismatched clocks strike together and many planets crowd into the same stretch of sky at once. Now, the honest accounting, because this video made you a promise about what your eyes will actually get. 4 of the 6 planets that morning are genuinely naked-eye objects. Jupiter and Mars burn bright. Mercury and Saturn sit lower and dimmer, but they're there. Uranus and Neptune are the fine print to spot them. You'll want a pair of binoculars, and you'll want to know exactly where to look. That's the honest shape of almost every planet parade, a naked-eye spectacle with a binocular bonus round. And one thing should be said plainly, because 8 centuries of history demand it. Nothing happens when planets align. Their orbits are tilted just enough that a true straight line through space is geometrically impossible. And even the loose version, every planet gathering in 1/4 of the solar system, occurs only about 7 times in an entire millennium. Harmlessly, the math has been done. Even a perfect lineup of every planet at its closest possible distance would tug on Earth's tides with about 1/6000th of the force the sun applies every single day. But people have never quite believed that. When 5 planets crowded together in the year 1186, an authority of the day predicted worldwide catastrophe, and records describe near panic across Europe. When the sun, moon, and 5 planets gathered within one small patch of sky in May of the year 2000s, there was talk of eruptions and tsunamis. The Earth, both times, did not notice. Hold on to that date, though 1186. It's going to matter enormously in a few minutes, because August 2026 is only the opening act. On November 14th of this year, a tighter, small alignment follows Mercury, Venus, Mars, and Jupiter together at dawn. On October 22nd, 2028, 1 hour before sunrise, planets will be strung across the entire sky from horizon to horizon. Mercury and Jupiter rising low in the east, brilliant Venus above them, Mars glowing beside the blue-white star Regulus in a striking color contrast, Saturn holding the west. And on February 3rd, 2034, comes the full set, a great alignment, with 7 planets, Venus, Mercury, Jupiter, Mars, Neptune, Uranus, and Saturn observable in the sky at the same time. Each of these, on its own, is a fine reason to lose a little sleep. But on this calendar, they are the rehearsals. The 2 main events of the 2030s are stranger, rarer, and one of them your eyes will remember for the rest of your life. First, though, the calendar takes a dark and crowded turn, because the early 2030s are the busiest stretch of skywatching in living memory, and they open with a farewell. January 2031. If the current plan holds, this is when the International Space Station comes home. Since its first modules launched in 1998, the station has grown into the largest single structure ever assembled in space, the size of a football field, more than 400 metric tons, built across 13 years, 27 space shuttle flights, and 161 spacewalks. It has held human beings continuously for more than 2 decades. If you are young enough, there has never been a single day of your life when everyone alive was standing on Earth. But the station is old. Persistent cracks, air leaks that resist repair, around $3 billion a year just to keep running. Every alternative to ending it has been formally studied, and each fails in an instructive way. Take it apart and bring it home? The modules were never designed for disassembly, and the shuttle-class spacecraft you'd need no longer exists. Boost it to a high orbit as a monument. Higher is actually more dangerous at 800 kilometers. The average time between serious debris strikes on a structure that size drops from about 51 years to under 4, and NASA estimated that a catastrophic fragmentation up there could degrade access to low Earth orbit for centuries. Let it fall on its own? Not permitted. Something this large must come down under control. So NASA hired SpaceX under a contract worth up to $843 million to build a vehicle with one purpose attached to the station and aim it. The final crew will depart. Then, over the emptiest water on Earth, a region of the South Pacific around Point Nemo, the point of the ocean farthest from any land, nearly 2,700 kilometers from the nearest island, a long final burn will bring it down. Engineers expect the solar arrays and radiators to tear away first, then the modules and the great truss to separate, then fragmentation. Most of it will vaporize. The densest pieces will reach the sea. For scale, the largest object ever deorbited before was Russia's Mir at 130 tons in 2001. This will be more than 3 Mirs at once. And here is the strange truth about this entry on the calendar. It's the one event deliberately engineered so that almost no one sees it. The whole design exists to put the fall where no eyes are. What you can actually see is everything before that, because until that final month, the station is still up there, still crossing the sky, still crewed. Some night, in late 2030 or early 2031, will be the last time human beings pass overhead aboard it. If the plans hold, new commercial stations will already be in orbit before the gap opens, but the first continuous human home off the Earth will be gone. And the era you were born into will have quietly ended, not with something appearing in your sky, but with something leaving it. Then, less than 2 years later, comes the near miss. December 22nd, 2032. The rock from the beginning of this story, 2024, YR4 returns, right on schedule. At 8:22 in the morning, Universal Time, it will pass about 278,000 kilometers from Earth. Read that number again. The Moon orbits at 384,000. A 15-story building made of stone, spinning end over end once every 19.5 minutes, will thread the gap inside the Moon's orbit, skim past the lunar surface at a distance smaller than twice the Moon's own diameter, and continue on its path, bent by the encounter, into a future that is genuinely hard to calculate. Now, the honest accounting again, you will not see the asteroid itself. At 60 meters across, it is far too small and dark for the human eye, even that close. What your eyes get that morning is something quieter and, in its own way, heavier. That night, the Moon will be a waning gibbous, about 70% lit. You can walk outside and look at it the same moon as always and know that for a few hours, a mountain fragment from the asteroid belt is sweeping past it, close enough that for an entire year, the best minds in planetary defense genuinely did not know whether that bright face was about to gain a brand new 2-kilometer crater while you watched. You'll see the moon that almost got hit on the morning it doesn't. On this calendar, that counts as a kind of seeing too. And it's the last quiet entry for a while, because 11 months later, the sky is scheduled to catch fire. To understand what may happen in November of 2033, you need to know what happened in November of 1833. On the night of November 12th that year, across North America east of the Rocky Mountains, people woke to shouting. When they stepped outside, the sky was falling. Not one shooting star, every minute, radiating out of a single point in the constellation Leo, hour after hour until dawn. One estimate put the peak above 100,000 meteors per hour. Another, made as the storm faded, reckoned 240,000 meteors over 9 hours. A 19th century astronomy writer, compiling eyewitness accounts, described them falling at Boston about half as thick as snowflakes in a snowstorm. No telescope was involved, just eyes, pointed up, which is precisely why the night burned itself into the memory of a continent. The Cheyenne marked it with a peace treaty. The Lakota reset their calendar to it. For decades, people dated their own births by it, born so many years after the stars fell. Harriet Tubman and Frederick Douglass took note of it. Abraham Lincoln was still talking about it years later. And on the banks of the Missouri River, Joseph Smith, leader of a refugee Mormon community driven from their homes days earlier, wrote in his journal that he took the spectacle as a literal sign of the end of the world. It's easy to smile at that, but in 1833, nobody on Earth knew what a meteor was. The prevailing view held that they were weather something in the air. One man decided to check. Denison Olmsted, a professor at Yale, spent the final weeks of 1833 doing something quietly radical, collecting eyewitness reports from Canada to Jamaica and treating the great omen of his age as a data set. Published in January 1834, his findings changed astronomy. The storm had lasted only hours and hadn't touched Europe, so it wasn't weather. And every meteor traced back to one fixed point among the stars, which meant the source wasn't in our atmosphere at all. Earth, he proposed, had plowed through a cloud of particles floating in space. He was right. Here's the machinery as we understand it now. A small comet called Tempel-Tuttle, a dirty snowball about 3.5 kilometers wide, loops around the sun every 33 years. Each pass, sunlight boils its ices, and it sheds a ribbon of dust along its orbit, one distinct ribbon per visit, each slowly warped over centuries by the gravity of the planets. Every November, Earth crosses the comet's orbit, and stray grains, most no bigger than a grain of sand, slam into our atmosphere at 70 kilometers per second, the fastest of any annual shower, burning up in streaks 70 to 100 kilometers overhead. Most years we thread the gaps between ribbons, and you get a modest drizzle called the Leonids, maybe 15 meteors an hour under dark skies. But when Earth runs through a ribbon dead on, you get a storm. The night of 1833 was Earth hitting the ribbon shed in 1800. The storms returned in 1866, then vanished, and when they failed to appear in 1899, astronomers declared the show over for good. They were wrong. In November 1966, over the Americas, the sky detonated for one 15-minute stretch. Observers counted thousands of meteors per minute, a rate exceeding 40 per second, and witnesses said they appeared to fall like rain. The fuel, we now know, was the ribbon from 1899. The very year that seemed like a no-show had quietly loaded the storm 67 years later. And then prediction caught up. Building on calculations from Kazan University, two astronomers, David Asher and Robert McNaught, cracked the problem in 1999 by modeling each ribbon individually and began forecasting meteor outbursts to within 10 minutes. Storms in 1999, 2001, and 2002 arrived on schedule at roughly 3,000 meteors per hour. The falling of the stars, the omen that reset calendars, had become an appointment. So here are your appointments. The comet itself returns to the inner solar system in 2031. In November 2033, Earth is expected to brush the 1899 ribbon, the same stream that produced 1966 with forecast rates between 35 and 400 meteors per hour. In November 2034, we meet the young, dense ribbon shed in 1932 with forecasts of 40 to 500 per hour. Label these correctly, they are predictions, not promises. Researchers also expect a close encounter between the comet and Jupiter to warp many of the streams, making storms of true 1833 scale unlikely for decades. But several hundred meteors an hour would still be the strongest display in a generation, and for younger viewers, the tables extend further. A possible outburst in 2061 from the 1998 stream, and around 2099, a flagged encounter with a dense stream carrying a tantalizing figure of 1,000 or more. And what will it cost you to witness it? Nothing. This is the most democratic event on the entire calendar. The professional advice amounts to this: get away from city lights, go out after midnight, lie flat on your back, taking in as much sky as possible, and give your eyes half an hour to adapt to the dark. Don't stare at Leo itself. The meteors look longest and most spectacular, 30 or 40 degrees away from their radiant. Then be patient until dawn. No telescope, no binoculars. The instrument this event was made for is the one you were born with. Remember 1186? The 5-planet gathering that pushed medieval Europe toward panic? It has not happened since. Ordinary alignments spread the planets across the whole sky. But a survey of the mathematics found something far stricter moments when the 5 bright, naked-eye planets, Mercury, Venus, Mars, Jupiter, and Saturn, all crowd inside a single circle of sky, 10 degrees across or less. Astronomers call it a planetary quintuplet, and across a span of nearly 4,000 years, only 9 of them occur. The last one visible from Earth was in 1186. The next is on the evening of September 8, 2040, when the 5 bright planets will squeeze into a circle just 9 degrees wide, smaller than your fist held at arm's length, with a thin crescent moon hanging among them. Sit with the arithmetic of that for a moment. Every astronomer who ever lived in the modern era, everyone who built a telescope, everyone who walked on the moon, was born into the gap between quintuplets. You were born at its very end. A child born tonight will be 14 years old on the evening the drought breaks. Now, the honest accounting, as always. This one has a catch, and the catch is geography. The grouping will sit low in the western sky after sunset, against twilight, and from mid-northern latitudes it will be difficult. From the southern hemisphere, the whole formation rides higher and sets later into darker sky. Which is why serious sky watchers are already saying, only half-jokingly, that 2040 might be the year to justify a trip south. For an event that comes once in 8.5 centuries, a plane ticket starts to sound reasonable. No equipment required. 5 worlds and the moon. In one glance of your naked eye. A glance no living person has ever taken. But not everything on this calendar is a date and a flash. One entry is a slow-motion event, unfolding right now, and it may be the strangest item on the whole list, something enormous that you can watch shrinking and that might not exist by the time you're old. Jupiter's Great Red Spot is the largest storm we have ever observed, a vast high-pressure vortex south of Jupiter's equator, with winds well over 400 kilometers per hour, spinning through one full rotation every 4.5 Earth days, and reaching, according to data from the Juno spacecraft, hundreds of kilometers down into the planet. It persists partly because Jupiter has no surface with no ground friction to drain its energy. A storm there can simply keep going, except this one may not be. A century ago, the spot measured about 40,000 kilometers across 3 Earths, side by side. By 2004, half that. By 2017, about 16,000 kilometers. Today, the storm that once dwarfed our planet is slightly smaller than Earth. In 2019, observers watched it flaking, shedding fragments of itself that spun away and dissolved. And, at the current rate of contraction, calculations suggest the spot will become fully circular by around 2040. What we know, we mostly learned recently, and it keeps getting stranger. We don't know why it's red. Laboratory work suggests sunlight breaking down chemicals lofted high in the storm, but the honest label on the most recognizable feature in the solar system remains origin unknown. We don't even know how old it is. The textbook story links it to a spot Giovanni Cassini tracked from 1665 to 1713, but the records then go silent for over a century until continuous observations begin in 1831, and a study published in 2024 suggests Cassini's spot, and today's, may not be the same storm at all. The original may have died unrecorded. If that's true, then great red spots are not permanent fixtures of Jupiter. They are events. They begin, and they end. As for why it's shrinking, a 2024 simulation study led by Caleb Keaveney, then a PhD student, who has said what moves him about the spot is the 2 centuries of ordinary, non-professional stargazers who watched it before him found that the storm grows when it absorbs the smaller storms Jupiter constantly produces, and doesn't when it can't. The largest storm in the solar system may survive by eating. A century of shrinking may simply mean it's going hungry. Some astronomers think it could dissipate within decades. Others argue we're only watching its cloud cover contract while the deeper vortex endures. Nobody knows. That's the point. And here is why it belongs on your list. This is not an event reserved for space agencies. That shrinking has been documented year over year by amateurs. The source imagery for its recent contraction includes a sequence captured through an ordinary 8-inch backyard Dobsonian telescope, the kind found at any stargazing club on Earth. Look at Jupiter through modest equipment tonight, and you are seeing the spot smaller than any astronomer in history saw it. Do it again in 10 years, and you'll see the difference yourself. Every other entry on this calendar is something appearing. This is the one you watch by its disappearing, the only era in recorded history in which the great red spot has visibly changed, and you are alive during it. Whether you're watching a storm change shape or watching it die is a question your own lifetime may answer. Which brings us, finally, to the last entry on the calendar, the rarest one. The one the sky has been withholding since before photography existed. September 12th, 1170, Canterbury, England. A monk named Gervase watches 2 planets, Mars and Jupiter, draw so close that, in his words, they appeared as though they had been one and the same star. Moments later, they separated. On the other side of the world, Chinese astronomers logged the same event and named it correctly an occultation. One planet had passed directly in front of another. Consider what has to happen for that. Every planet's orbit is tilted at its own slight angle to ours. So for one planet to cross the visible face of another, 3 worlds, the 2 of them, and the Earth must fall onto a single straight line through space to within a hair's width of sky. Conjunctions, where planets pass near each other, happen every year. This is something else entirely. In 1979, an astronomer named Stephen Albers wrote a high-precision program and searched nearly 7 centuries of sky, from 1557 to 2230. He found 21 such events, total. And humanity has all but missed them. In May of 1737, at Greenwich Observatory, an astronomer named John Bevis watched through sliding clouds in brief stolen glimpses as Venus swallowed Mercury whole, and his notes remain, to this day, the only detailed account any human being has ever made of one planet occulting another. One cloudy evening, one man. That is the entire archive. There's even a near miss that borders on tragedy in January 1613. Jupiter passed in front of Neptune, a planet nobody knew existed, and days beforehand, Galileo himself, studying Jupiter, saw Neptune through his telescope and recorded it in his notes as a star. Now the fact this entire video has been building toward, it deserves a moment to breathe. The last time two planets crossed in Earth's sky was January 3rd, 1818. Venus passing over the face of Jupiter, above the sparsely populated Far East, where not a single record of any witness has ever surfaced. And since that day, it has not happened once. Not in the rest of the 19th century. Not in the entire 20th century. Not one event between the invention of photography and the moon landings and beyond. Every camera ever built, every astronomer who ever lived in the modern age, has existed inside a 247-year gap. No human being alive has ever seen it. And you are scheduled to be the first. November 22nd, 2065. At about 12:43 Universal Time, Venus will glide across the face of Jupiter, appearing as a small, brilliant disk, about a third the width of the giant behind it, and at their closest, the two planets will merge into a single point of light at magnitude -4, as bright as Venus ever gets, but made of two worlds. There's even an opening act about 80 minutes earlier. Venus will first pass in front of Ganymede, Jupiter's largest moon, in an occultation visible from the southernmost parts of the Earth. And now the honest accounting one final time, because this is the hardest ticket on the list. The event happens just 8 degrees from the Sun. That is too close for the naked eye. Watching it will require optical equipment and proper solar protection, and the best views will almost certainly come from telescopes in space. The comfortable, well-placed rerun Venus crossing Jupiter again, a full 16 degrees from the Sun, over the Pacific, doesn't arrive until September 21, 23, and very few people watching this video will collect that one. Do the arithmetic on 2065 instead. A child born tonight will be 39. If you're 20 today, you'll be 59. If you're 40, you'll be 79. For almost everyone watching, 2065 is not the best chance to see two planets become one. It's the only chance you will ever get. So here is your list, complete, in order. August 12th, 2026 weeks from now, 6 planets at dawn, 4 of them for your naked eye. October 2028, worlds strung from horizon to horizon in the morning dark. January 2031, the last nights of the first human home off the Earth, and a sky that will never again carry that particular light. December 22nd, 2032, the moon you'll look at, knowing what is threading past it. The Novembers of 2033 and 2034, when the sky may rain, for free, for anyone lying on their back in the dark. September 8th, 2040, 5 worlds and a crescent moon inside one glance, the glance no one has taken in 854 years. Alongside all of it, in any backyard telescope, the largest storm in the solar system, visibly deciding whether to die. And at the end of the list, November 22nd, 2065, the day the 2.5-century drought breaks, and 2 planets become 1 point of light with you, if you make it, among the first human beings ever to watch. Notice what's not required. No spacecraft, no observatory, no luck. For thousands of years, sights like these arrived as omens. The stars fell and calendars were reset. The planets gathered and continents panicked, and the one thing no one ever had was warning. You have warning. You have the dates, some of them accurate to the minute, and you have the only instrument most of them ask for, and you've had it since the day you were born. What you don't have is unlimited time. That's the honest trade written into every line of this calendar. The events are certain, and you are not. Nobody knows how many entries on this list belong to them, but that, strangely, is what makes the list beautiful. The universe has finally shown us its schedule, and for the first time in the whole history of looking up, the only remaining question is not what the sky will do or when. It's whether you'll still be standing under it. So keep the dates, stay curious, and when the nights come, walk outside, because the sky has already promised to show up. Now it's your turn.